Hey guys, welcome back to another Leetcode problem solving tutorial, and in this tutorial I'm going to be showing you guys how to solve Leetcode question 143, asking us to reorder this list in a specific order, a linked list, and basically we start from the front, go to the end, go to here, and we just sort of like spiderweb crawl into the middle. So I'm going to show you guys the algorithm which we need to use in this problem, and yeah, so we start off with this linked list, starting off at node number 1. And the first thing we want to do is we want to get to the middle of the list, because what we want to do is we want to get the second half of the list, reverse it to get 4, 3, and then we want to sort of merge these lists together like this, so we end up with 1, 4, 2, 3, like that. So that's the idea, and first step is get to the center of the list, and to do this we use a fast and slow pointer. So if I just call these fast and slow, essentially, the fast pointer is going to move 2 steps every time the slow pointer moves 1. So we start fast at pointing to 1, and slow is always also pointing to 1. Now fast moves 2, whereas slow only moves 1, like this. And then we're going to say, well, our break statement for the fast is going to be if the current node is none, like if we were here, or if the node.next is done, neither of which is true, so we go back and we add one more, we also add one more to slow to bring us here. At this point fast is none, so we break the loop, and that leaves us on number 3, which is the center. Now you can imagine if there was a node here, 5, well fast would still break because our break condition is whether fast is none or fast.next is none, and fast.next is equal to none. So we'd still break here, which means if there was an odd number of items, we'd get the exact middle. If there's an even, then we get the higher middle, because when there's an even, there's 2 middle items technically, but we'll get the higher one, which is good because it's the one we want, right? Like we want this half of the list. We don't want the slow one to stop here and then we reverse this, because we want the list to be of even size. Alright, so now that we've done that, we can sort of split them apart. So we can take the fast, or we can just start with the original list. So we'll have 1, 2, and notice that slow is also going to be here. So we have 1, 2, 3, 4 as the original list, and slow is currently at this index. So this is what slow sees. We see slow only has 3 and 4 like this. And what we want to do is we want to reverse slow. This is a pretty easy algorithm. We can just do something like store slow in, we'll store all this stuff in a temp variable. So this is the temp, and then slow is going to be the current. And then what we do is we can just simply add slow to the temp. So each time we add slow to the end of temp and then increment slow, like so, if that makes sense. So just a basic reverse list formula, reverse linked list algorithm, and then we end up with, these are our 2 lists. So we're going to have 1, 2, 3, and I'm pretty sure if we use this algorithm, it's also just going to get rid of everything after this 3, which is fine. So we'll just do 1, 2, 3, that's what we start with, and slow is going to be 4, 3. And what we now want to do is we start at temp, we start the first item in current, and we're just going to repeat until, we're just going to keep linking to the opposite list until slow.next is equal to null. Because slow is almost always going to be a limiting factor. This is always going to have at least 1 or 2 more. So slow is always a limiting factor, and that's how we end up with using slow as a limiting factor, because now when this links over to here, this is going to be none, and we end the list, and yeah, now this has completely been disregarded, so we just return this, which is the answer. So hopefully that made sense. This is pretty standard, just using standard algorithms but pairing them a special way. And there's multiple steps to this program. So let's get implemented. We get a list node. Okay. So first thing we're going to do is find middle of list using slow and fast pointer. Remember, you can't just find the middle like by index because this is a linked list, not a regular list. So we'll set fast and slow to initially both be the head node, and then our break condition is going to be, well, while fast is, okay, yeah, so while fast is not equal to none or null, and fast is fast.next is not equal to null, like so. There's our break condition, and for each iteration we just increment fast by 2 and increment slow by 1. And we can actually force unwrap this because slow is always going to be behind fast, so as long as fast exists, slow is definitely going to exist as well. So there we go. Now slow points to middle node. We want to reverse slow. I've already made a video of this in the past, but we're just going to use a linked list, reverse linked list algorithm. So if this is the node we're given, we need to split this into two parts. We'll do the storage, which is slow.next. So storage, essentially storing all the items left. So storage is slow.next, and we're going to, one sec, can I just force unwrap node? Okay, let me just, I think if I do something like this, then, never mind. We'll just have to keep force unwrapping it. So yeah, we set the storage to be this, and then we just completely disregard that from slow, just to, so now slow is just on its own and we have the storage. And what we're going to do is, let me think. Okay, yeah, so we want to repeat while storage is not equal to null. So while there are still items left in storage, I think it would be easier if I choose a bigger example. So let's just say we're trying to reverse this entire list. We'd have this as the original thing, and then storage is all of this. And essentially we're just trying to flip these pointers. So we'll do storage is pointing to this node. We do storage, we have to, but if we flip this pointer over here, then we need to store that somewhere else, so we use a temp variable. So const temp equals storage.next. Then we set storage.next equals to slow, like so, so this points over to there. And then we set slow equals to storage. So we've created this, and then we just want to reset to make this slow now, and reset to make storage equal to temp, like so. So here's simple reverse algorithm. Now slow is reversed. So once we have something like this, we're going to have the initial head node, and we're going to have the slow node. And we now need to use the sort of merge algorithm. So so let's say we're here, and let me make this a bit clearer. Do this again. So this is our head, and this is what our slow looks like. So our head starts here, and we move this over to there. So now we've got this as a list, but we need to store this somewhere else so we don't lose it. And then once we've done that, we now here, we point over to here, now we need to store this, and then we're here, we point this over to here, and we need to store this. And I guess what we can do is we can just, our break statement is going to be while head.next is not equal to null. So because once we get here, we don't want to add this because this is going to be a duplicate, but essentially we're checking if the next item in head is null. That means that there's no more items left to add, and to add this we can just perform a swap. So we just use head.next and temp. We're basically going to swap them. I can make this a bit clearer by using a temp variable. So now head.next, we're pointing this to the temp variable, and we need to make sure we store the remaining heads in this temp, so we set temp equals to head.next, like so. There we go. So there's the algorithm. It's a bit confusing at first, but this is, oh, don't have to return anything because we're modifying head in place. Modifying head in place, so don't return anything. And you can see we're essentially just performing a merge algorithm to interlace these two lists, and we're going to break when this head is got no more elements. So yeah, this was how we solve this question. Let's see what we get, and let's check if there's any kind of errors first. Okay, we get a time limit exceeded. Right, that's unfortunate. And let's see what's going on here. So while fast is not equal to null. Okay, so let's do a bit of testing because this is a bit hard to get all the parities right. This is a pretty annoying off by one sort of situation, but it's alright. So let's just define a list as this. And let's see what happens when we try and call this function. Reorder list this. What's going on here? Expected. Oh, I see. We need to finish this off. Okay, there we go. Alright, so let's see where the problem is being caused. So I'm going to print here to check if we make it past this stage. Let's just run reorder. Reorder list slash script.ts. Okay, so we get there. Now let's see if we get here. Alright, we get there. So I'm assuming the issue is here, right? Oh, it's not even here. Oh no, we didn't. Okay, yeah, so the issue is in here, in the merging of the lists. So let's attempt to fix that. Okay, yeah, so I think we don't have to use head.next. Okay, so the issue is because when we perform this swap, head.next is here. So head is actually pointing here, but temp is here. So instead of checking whether head.next is null, I think what we can do is we can just check while temp is not equal to null. And hopefully this solves our issue. Nope. Okay. Let's have a look at our variables, how they're stored. So let's print what temp looks like and console.log what head looks like. Okay, so this is what head is. Yeah, exactly what we expect, and this is what temp is, exactly what we expect as well. Okay, and let's just think about this algorithm a bit more carefully, since it is a bit confusing to implement properly. So we're going to get 1, 2, 3 like so, 4, 3, and we want to interlace them like this. So interlace that, store that in temp, then interlace that, and store this in temp. And then if we interlace this, so head is currently there, if we interlace this, now store this in temp. Okay, yeah, so I think head.null, I think checking if head is not equal to null was the correct move. So I'm not sure why it hasn't worked. Let's just console.log. Let's just see what's happening with the head throughout this. Let me just... Okay, so okay. We've got a crucial step. We set head.next is equal to this, is equal to temp, and we perform a swap, but then we also need to remember to increment head.next. So we've done this, and then we just need to increment head to head.next, like so. Here we go. Okay, that should do it. So we forgot the most important step of just moving head along, incrementing it to the next counter. Sorry for that slight blunder, but now let's check if this works. So right, okay. Output, so we get 143. Not what we're looking for. And I think here I can just check if temp is equal to null. I think that would work. So let's just console that like this. It appears to be circular. Okay. If I do that, and then if I do that. So it goes 1, 4. That's quite weird. Wonder if that helps. Okay, there we go. So I guess it's a bit confusing because when we do this, everything's stored differently. We need to execute the swap first and then increment. There we go. Okay, so yeah, you can see how linked list can be a bit annoying sometimes. Hopefully that's all we need. And okay, yeah, there we go. So that was quite a long solution. Definitely could have been shorter if I didn't make that mistake. But yeah, these 83%, so decent solution. We're basically finding a middle item, reversing that, and then merging them together. Thanks for watching, and I'll see you guys in a future tutorial. Bye.